Bismillahirrahmanirrahim. Assalamu alaikum students. This is Tariq. Today our topic is the concept of outliers. In this section we are going to learn about the outlier and the negative effect of the outliers on the mean value of the given data set. So first we are defining what is outlier. What is outlier? The largest or smallest value means extreme value of the data set is called outlier. Outlier will negatively affect the mean value of the given data set. So its mean outlier is the large value of the data set or the small value of the data set. That particular data item which is very large in the given data set or very small in the given data set, that particular data item is called outlier, which is different from the all other given data items in the data set. That particular data item is called outlier of the data set. I am again repeating, the very large value or the very small value of the data set which is different from the all other data items of the set, that particular large or small value is called outlier. Now we are elaborating the concept of outlier by putting one practical example. For example, Etisalat company send a request to BBA department of Salam University. They want to know the salary expectations of the BBA department graduates. So we have to compute the average expected salary of the BBA department graduate. Expected salaries are as given in the below table. So this first column define the 5 different names of the 5 students. This is the sample data. We just take only 5 students from the entire BBA department at Salam University. So the first column define the number of students: Shafiq, Majid, Obaid, Yusuf and Imran. And the second column represent the expected salaries of these 5 students in dollars. So Shafiq is expecting $1,000, Majid $900, Obaid $1,200 expecting, Yusuf expecting $1,400 and Imran is expecting $800. So this is the given data set. In this data set, the minimum expectations are $800 and maximum expectations are $1,400. This is very clear from this data set. So we will just simply compute the mean value, that what is the average expected salary of all the graduates from the BBA department of Salam University. So the simple mean formulation we studied before this few times. I am again repeating. Note, simply by adding together all the 5 data items and divided by the sample size we have. So the sample size, symbol n, that is 5. We have 5 students, 5 data items, and this is the formulation. X bar represent the average value, the mean value, arithmetic mean. Simply just add together all the 5 data items: $1,000 expected salary plus $900 expected salary plus $1,200 plus $1,400 plus $800 and whole divided by the sample size, which is 5. So when we add all these 5 expectations, the total value is $5,300 and we are dividing by 5. So the expected average salary that we calculate using the symbol X bar for the mean value, $1,060 expected average salary. So we use a simple mean and we compute the average salary of the graduates of the BBA department. So interpretation is this, that every BBA graduate is expecting approximately $1,060 salary. Now to clarify, to check the effect of outlier on the average salary, suppose I am changing that Mr. Imran, the last student, Mr. Imran is expecting $10,000, not $800. We change only one student expectation, that is Imran. In the previous table, the expectations of Imran we put here $800 and we calculate the average salary $1,060. But now we change the expectations of Imran and we include $10,000, which is a very large value, as we define that outlier is the large or small value of the data set, which is different from the all other values. So this $10,000 is very large value, and this is different from the all other remaining 4 students' expectations, 1,900, 1,200, 1,400. So this is very huge difference. $10,000 is very large value. The differences between the salaries of the students, that is minimum $100 or maximum $200. But Imran is expecting $10,000, that is very large, and that is why this $10,000 is called outlier, the largest value of the data set. And now we are redefining, recalculating mean value, average value for this second data table, that what is happening to the average value if there is a large value or small value in the data set, if there is an outlier in the data set. So let me start from this note. Let Imran is expecting $10,000 salary, which is the extreme value, which is the outlier of the data set. What is the expected average salary now? When we have outlier, we have extreme value, we have large value in the data set. So in this section, we will learn about the negative effect of the outliers on the mean value of the given data, as well as the misinterpretation of the data set if we have the outliers in the data set. So again, just compute the mean value by adding together all the data items and divided by the sample size we have. So the sample size is again 5, and we are going to add together all the 5 expected salaries, 1,000 plus 900 plus 1,200 plus 1,400 and plus the outlier extreme value $10,000 and whole divided by 5. So when we add them together, we find the total value $14,500 and whole divided by 5. So X bar mean value is equal to 7250 expected average salary. Average salary mean value we calculate $7,250. So now before this outlier, before this large value $10,000, the mean value was what? I'm taking you back. This was $1,060, which was acceptable. The differences between the students' expectations are minimum $100 or maximum $200, and in here we compute the average salary $1,060. But after including outlier, large value $10,000, now the mean salary, expected salary, average expected salary, that is $7,250. So this is the wrong calculation. This huge expectation average value is only because of the one student that he is expecting $10,000. So this outlier $10,000 negatively affect the average value of the data set, because this $7,250 does not even represent the expectations of the graduates of the BBA department, because expectations are minimum $800 and maximum $1,400. You can see from this table maximum $1,400 expectations of the students, but in here only one student is expecting $10,000. Maybe Imran has his own business, or he is working in family business, or his father has factories, large business he can expect. But every student who is graduating from the BBA department of Salam University, he is not expecting this much huge $10,000 salary. So this salary even does not represent the expectations of the students of the BBA department. So that is why we are saying that outlier is negatively affect the mean value of the data set. Now, how we can avoid this problem? Let me interpretation. This expected average salary, which is $7,250, this is very high. It does not represent the given expectations of the BBA department graduates even. Expectations are minimum $800 and maximum $1,400. $10,000 is the exceptional salary. Maybe Imran has his own business. He is working in his family business. He is billionaire. He can expect, but every graduate cannot expect. Most of the students does not expect this much salary. In this case, mean is not a good measure to interpret the data set. So it's mean we cannot apply this mean value to the BBA department of Salam University that every Salamian is expecting $7,250 because no one will offer them job. So this expectation is wrong because of only one value, which is the very extreme large value, and that is called outlier, and that is the bad negative effect of the outlier. How to avoid this problem? How statistician can avoid this problem? Statistician has to eliminate this large or this small or this extreme value from the data set and calculate the average value and interpret the data. This is one way to eliminate this large value. For example, statistician has to eliminate, we have to eliminate the expectations of Imran and then calculate the expected average salary for only 4 students. It will be correct answer. But if we are including outlier, then it is incorrect mean value. So one way, eliminate the extreme salary of $10,000 from the data set. Another way, statistician can overcome this problem, can avoid this problem just using another statistical measure, which is called median, because outlier does not affect median. What is median? We will discuss inshallah in the next section. This is coming. This is a new another statistical numerical measure. Now let me jump toward the disadvantages of the mean. We are learning about the few drawbacks while using statistical numerical measure mean to compute the average value and to interpret the data set, to understand the data set, to make the data set meaningful. Mean carry few drawbacks, few disadvantages. The first one, mean is negatively affected by extreme values, as you check in the previous example that this $10,000 is a large value outlier and it negatively affects the mean value. So this is the first drawback of the statistical numerical measure mean, that extreme value badly affect the mean value and we cannot interpret the data set in correct way. This is first drawback. The second, statistician has to count every data item of the data set if statistician is going to compute the mean value using numerical measure mean, and this is very time consuming. Again and again we put a note that when we are computing the average value, the arithmetic mean value, so we have to add together all the data items. So if the data set that is large population data, so statistician has to count all the data items, include all the data items and then divided by the sample size. So this is very time consuming. Statistician has to include every data item. This is second drawback. The third, we cannot compute the mean of the open-ended classes. Like suppose this is a class starting from first number 1, 2, 3, 4 and so on. So the last number is unknown, and in mean value we are including all data item. We have to add together all the data items. So if the first end or the last end of the data set is unknown, not given, as this is clear from this example. After 4 we do not have data item, but this set is extending. This is open-ended class, so we cannot compute the mean value for the open-ended classes using arithmetic mean numerical measure.